last of the cycle 1 notes. We're gonna play with these just a little bit into next week. We should be done before you guys have your nice long weekend next weekend. So we're gonna do a couple of shapes a day, and then once we get that done, we're gonna start combining them and doing areas of shapes inside of shapes and some things like that. So it's Friday. We're gonna keep it simple today. Simple area and perimeter, a few different quadrilaterals and triangles, but we're going to have all of our notes here, so we should be able to take this up. Okay. So, question at the start. I know we're not even a minute in and I'm already asking questions. What's the difference between area and perimeter?
One is squared and one is not.
Okay. Area, that's true. The amount of area that a figure takes up, it's going to be, I'll just use feet as an example, it's going to be in square units. Because when we're looking at a shape, trying to figure out all the area it takes. If you're measuring, like, let's say carpet for something, you're trying to see, okay, how much carpet do I need for this room? That'd be area. Perimeter is the distance around a figure. So if we were doing feet, it would just be feet. And we'd be trying to figure out just what's going on along the edge. Of course, I don't have an example in here to use because they don't have it, but if you have, molding along a floor or something like that, that would be something we deal with the perimeter area. So, squares, we like squares because there's only one side to deal with because they're all the same. So we can square a side if we're looking for the area. We can just add up the sides or multiply one side by 4 if we really want to be quick and slick here with stuff. So as we go through, my area, I don't want to leave it as 3 squared though. You wouldn't walk into Home Depot and say, hey, I need 3 squared of that type of carpet. They'd kind of look at you funny. But the one thing that's going to be important no matter what type of shape we're working with, if it's area, label with whatever the measurement is and make sure that squared is there. Because that lets me know that you know what's up with these. Now, perimeter, I got to be careful. Yes, we're adding up the sides, but if I just do 3 and 3, that'd be 6. That's not right. So either you can write in the other sides and add them up. Or like it mentions over here, since all the sides are the same, you could just do 4 times the side and get there that way too. So whichever way works for you, I say roll with it. Most of these I'm going to assume we're going to be okay with. I know it can be dangerous to assume. Rectangle, area is length times width. I'm just going to put that out here. Get my square inches. Now, perimeter, we got to think a little more. Because here, not all the sides are the same. The opposite sides are the same, though. So at this point, I could add them up. That would work. Or notice over here, there's a formula. You can take 2 times the length and then add 2 times the width. Punch that in your calculator, use the old noggin, whatever it happens to be. And I can get there that way. Those are probably the ones we're most used to. Triangle probably comes in a close third. But as far as some of these other ones go, like the parallelogram here, okay? Now this is where it gets a little more interesting. So base times height, but the base can be any side. The height is always perpendicular or makes a right angle to the base. Now most of the time, are we just going to go up and down? Yeah, that probably is going to be true. So when I'm trying to figure this out, we might be used to always seeing our base here at the bottom. With a parallelogram, okay, you can always make the assumption that your opposite sides are the same. That can come in handy because here now, here's my height, here's my base. I can easily find that and then multiply them together. So 20 times 11. No, Hardy. You said right there it's 10. Why am I saying that it's 11? I even labeled it and I wrote it wrong. What the heck? I'm going to blame the fact that it's Friday. That sounds good. Hardy, there's no units anywhere. They didn't put feet, inches, or anything. What are we going to do? If they do that, I know it's going to seem weird. We'll just say it's units squared. Let's use U. That's fine. That's just kind of a bonehead thing that happened here, I think. Let's see if I can redeem myself here. Okay, this is me again. I don't really think, to be honest, A plus 2B plus C is the smart way to go here. I'm going to do this the same way I did basically with my rectangle there, where I can see my opposite and kind of look. So I'm going to do 2 11s and 2 20s. Or just add them all up. It doesn't matter. Either one's going to get me to the right answer. So let's see here. 22, 40, 62 units as we go. But yeah, definitely use the height, not the slant, like I decided I was going to try to do here at the first piece. Triangles, base times height divided by 2. I like that one a little better. Again, the height is going to be perpendicular. We got to find that little right angle. That's going to help us out. So does that always have to be in the middle of your triangle, though? It doesn't. Wherever that right angle gets created, that's where your base and your height are. Okay? Well, what if I said that was the base and that was the height? That would work too. As long as I find the two sides that create that angle, I'm in good shape. So base times height divided by 2. If you're going to do it all in the calculator at the same time, well, that's going to end up the same answer this time. All right. Yeah, parentheses are a good idea in general, even though, like I said, this time, you'd get the same answer even if you didn't do it. We just would get lucky. Pure luck. We don't want to work on luck. We want to work on skill here. And add up all the sides. And then the last two are the craziest two. So the last two, we have got to find, I usually say find your height first, because then it's going to be easy to find the bases. If I find my height first, the bases are connected by your height. So then I can look and go, hey, here's my bases. Which one is base 1 and which one is base 2 really doesn't matter. But just making sure that we get those. So, base 1 and base 2 times my height divided by 2. I'm a fan, always have been, always will be, of I'm just going to do the top, the numerator, and hit enter, then do my divide. Then I don't have to worry about the calculator doing silly stuff. And for my perimeter, we're just going to add them all up. No fancy formulas on the trapezoid. Whew, one last one. You kind of forget how many shapes there are until you get in the middle of all this, and then it's like, okay. Now, this one's a little more interesting. Note, the diagonals of a rhombus or a kite are perpendicular. The key keeps being, and as soon as I say to find the right angle, of course, my example, I don't have a right angle in it. But we can kind of see where the right angle would be. Because the diagonals that we need are going to create that right angle. But here's the thing. The numbers that are given to me in here aren't necessarily the numbers exactly I'm going to use, because I need the whole diagonal. So I got to add up both pieces. The other diagonal, I need the whole diagonal. get both pieces. Then I can use the formula. Diagonal 1 times diagonal 2 divided by 2. Oh, no units again. Hardy. But then for the perimeter, we're just going to use the outsides. And just a reminder, if they're not all given to you, these little marks just mean they're all equal. They're all congruent. So all of these are 5. So lots of 5s. I guess I could have just done 5 times 4. That would have been basically the same dealio. So I'm not going to go crazy on the note part on the back, but I do want to mention one thing when we get back here, because actually I see 2 that I want to mention. So when we flip to the back of this page, it's not often we're seeing double page notes, but hey, occasionally we got to do it. I got a couple problems back here I want to go over with you, just to make sure that with the weird ones, we're okay. So when we flip to the back, in a regular shape, okay, it's not just one shape, it's 2 shapes put together. So in those cases, we're allowed to split the figure up into shapes we're used to seeing. And so when I do that, so I'm just going to do it with a design here. So I've got my rectangle here. So we're finding the area and the perimeter. Okay. So the area of my rectangle, there's my length and my width. Luckily, I don't have to do a whole lot of work there. And we're in feet, so that would be square. Then I've got a square down here. And with a square, if you know one side, you know them all. So the area of my square is just going to be 7 squared, or 7 times 7. And once I know the individual areas of my figure, I can just add them up and get to my answer. So most of the time, area is going to be my tricky part, but maybe not so much this time, because I look and I'm like, well, the square is going to be easy for my perimeter. 7 plus 7 plus 7 plus 7. You're like, okay, so 4 times 7 is 28. Okay, I got that. But then there's the rectangle. Don't get thrown off by this 14 that's down here. That can kind of mess with some stuff, and to be honest, that's interesting. Okay. The reason I'm saying that's interesting, now did I do something screwy? Oh, is Hardy gone cuckoo for the second time today already? Did I make a bad assumption? I might have. See, this is where you got to take all your information into play. Okay, here's what I did not think about, and I got caught. I made an assumption. You know what happens when we assume. I assumed that since that looked like a square, that it had to be a square. But I didn't take the whole picture into account. Here's what I mean. If I looked at the whole thing in advance and said, okay, oh boy, I made a mess out of this. All right, let's see what I can fix on this. Or am I just going to eat my words? I'm going to eat my words for a minute, and then I'll explain to you where I screwed up, and you'll get to see. I'm going to roll with what I have, even though I did something wrong. Oh, Hardy. Normally, if I'm looking at a rectangle, I'm like, okay, so I got 2 9s, I got 2 widths, I got 2 lengths. Friday follies for Hardy. All right. And if I'd have done this correctly, we'd add those up, but I didn't. So, okay, Hardy, where'd you screw up? Well, I noticed once I got in here, I'm like, wait. If this is 9 feet, and this is 7, what's 9 plus 7?
16.
16. Uh-oh. Man, don't anybody ever hire me to lay carpet or flooring in your house. I'm going to screw this up. So instead of taking the information and saying, okay, since this is 9, this has to be 5, and then looking at this and saying, hey, since this is 7, and this is 10, this has to be 3, and building it the way that I should have. Oh, gracious. So, I'm going to make one little drawing over here. Just so you have a correct reference. I'm just going to put oops over here. Like, that's still, my math is good. It's just not for the shape that's there. It's not very good. So, hang on. Quick shape update. So 9, 10, 14, and 7. Okay, the correct way Hardy should have taken this into consideration. This is 7, this is 10. Tells me this is 3. Because 7 plus 3, this piece plus this piece equals that piece. This is 9. Whole thing's 14. So if this is 9... this has to be 5. So yeah. So if we went back then and did it correctly, we would have broken this into shapes. We would have had our 9 by 10. So our area of our rectangle was still right. But over here, instead of what Hardy got with all the 7s, it'd be 5 and 7 and 5 and 7. To get to the writing. We live and learn. We live and learn. No more assumptions. I got another chance here to redeem myself, so hopefully I will be able to. With our final play here. Our final play. Am I gonna play? I'm almost afraid to try both of these, but I'm gonna do it anyway. Alright. Parallelogram where I'm not given the base inside. You're like, what's this going on out here? This isn't part of our measure. This is just an opportunity for us to be able to calculate that if we needed to. Because again, when we're doing a parallelogram like this, our area is our base times our height. So here's my base, here's my height. Because again, what creates the right angle is going to be my base. I'm busting out the calculator this time. No more trusting my brain this morning. Okay, so I've got my area. I'm feeling good on that. So now, my perimeter. Be cautious. So I've got 2 of these that are each going to be 5.8. And I got 2 of these, which are both 4. Now we're feeling a little better. 2 times, get back in here, 5.8, 2 times 4, 19.6. Much better. Good recovery. Okay. So sometimes some information will be there to help you on part, but it's not needed for both. And it's the same thing going on with our triangle here at the end. Here, I can't really get a height for my triangle inside, so it's given to me outside. So for my area, we've got base times height. Ooh, now let's think about this for a minute. Base. What one of those numbers there is going to be my base? 4. Okay? We're not trying to extend this all the way out. This is the actual triangle, so that's going to be my base. Nice play. And then my height's a little easier to work with because I can see that. So base times height divided by 2. And then the perimeter is not as bad because I can physically see where all my sides are. 27. Okay. The rest of them are fairly straightforward. So I'm another one of those combo shapes. I'm scared. Just saying, just scared. Actually, let's do this. Last thing, and then we'll get you the practice. I'll even cut it back for the other delay here. Try out number 5 with the 2 pieces putting together and see if you do a better job on your own than me trying to lead, because that can get to be a little bit of trouble here, it looks like. So I'm frozen, not for like real, but just a little bit. Then we've got never felt so much pressure on a question in my life. Let's see here. Oh, for the love party. I caught myself this time before I did something silly. People watching this later are like screaming at their screen going, dude. Okay. Problem fixed. Hallelujah. Let me make sure I didn't do anything else goofy. Oh, for the love. This is, if you ever need a good laugh sometime over the weekend, go back to this lesson and watch it again, because I cannot believe some of the stuff that I just did. Okay, 6 and 3 and 5. Some of you are like, Hardy, we're waiting. Like, you're taking forever. I know, because I get more and more scared by the second here as I'm doing this. Okay. Okay, I finally, wait till you see this when I unfreeze that. You're going to be like, you didn't learn it all, Hardy. I didn't. It's like, what the? So let's see. This is like everything not to do. So my answers are good now. I'm 100% confident of it. So what goofy things did I do the first time through? On my triangle, I made my height 5. That's definitely not my height. That is not making the right angle. It's 4. Fix that. Then I went back and I looked at my perimeter, and I tried to add the 4 in for my perimeter. Well, that's not on the outside of the shape, Hardy. So I had to go back and I had to add up all my sides again. So this is 30 square feet, 24 feet for my area and perimeter. Holy moly. That was just, yeah. So my total area? So, okay. So on my triangle, let me actually do this so I can do it on screen. What color do we want? Let's do blue. So, all right, so on my triangle, there's my right angle. So here's my base and my height, my 3 and my 4. So I just want half of that. So 3 times 4 divided by 2. Okay, so that part's 6. Over here, if I just went with the parts they gave me, the colors here, I've got a base and a height number. They can be interchangeable. So that would just be 6 times 4. And then just add those 2 together. Absolutely. So that's kind of what we're playing with here after our little bit of a rocky start and finish to this. So